Okay, AP Chemistry, here's a review of the lab that you did today and the tips on how to find the molarity of the hydrochloric acid or the analyte, which is what you were testing for. Quick, here is our formula. Whenever we do a titration, it's good to make sure we are looking at and referencing the equation, especially when we are trying to figure out the molarity of one of the reactants. So we have sodium hydroxide plus hydrochloric acid. Classic neutralization of a acid-base neutralization produces water. Plus, inside of that water, we're going to have some ions. In this case, sodium and chlorine. These will be separated if we are going to want to collect the sodium chloride, which this would form. We would first have to heat off or boil off this water, and then we would see the salt reform. Okay, but as it sits in solution, this is actually dissolved. This side of the problem, in this case, doesn't really matter. We're just trying to see what the concentration of this hydrochloric acid is. And this is what we call the analyte. Okay, so we're analyzing what the concentration is, or our term M, molarity of. Now you had a solution that you created of this. Okay, that's our titrant, our known quantity. Okay, we know what the concentration of that is. And our basic setup, here's our burette, and here's our Erlenmeyer flask. Okay, so the HCl was in here, and the sodium hydroxide that we knew the concentration of was in our burette. Okay, so drip, drip, drip in there until the pink phenolphthalein turned, or till the clear phenolphthalein turned pink when we hit to the point where we had more of a basic solution. Okay, so I'm going to use some numbers that I made up, or I did with my sample version of this. You all have different titrant concentrations. So we started off with a molarity for me of my NaOH being 2 molar. You guys range from 1 molar to 0.1 molar. And you had 100 milliliters or 0.1 liters of the hydrochloric analyte. That is what we had down here in our Erlenmeyer flask. Okay, so sometimes I like to write this on the side here. So when I did my lab, I used 0.065 liters of sodium hydroxide when I neutralized 100 milliliters of hydrochloric acid. Okay, so this is the data that I got from my lab. Okay, so I used this much. This is how much was dripped into the Erlenmeyer flask from the burette, okay, while I'm neutralizing my HCl that's down here. Okay, so basically what we want to do this is, it's kind of, you can think of this as a 4-step sequence. First of all, we're going to take the molarity of the NaOH, and from there we need to determine the number of moles in the NaOH that was used. Okay, so this is what gets poured out of the burette, okay, or dripped out of the burette into the Erlenmeyer flask. Okay, from the number of moles of NaOH, okay, we're going to do a stoichiometry problem and determine the number of moles of hydrochloric acid. And that's the hydrochloric acid in the flask. And then finally, we're going to find the big M, or the molarity of the HCl solution in the flask. Okay? So when you think about it this way, it kind of breaks down our process a little bit, and then we'll get to the point where we'll look at our equation up here and determine how we bridge this from moles to moles. Okay? So our molarity of NaOH is, I'm starting with 2. You'll start with your own quantity. And what that means is this: I have 2 moles for every 1 liter of this. Okay? Now 1 liter is a lot of liquid, so we're not going to use that much, obviously, because we're using smaller quantities. we want to go from the molarity into the moles of NaOH. When I do that, what I'm going to multiply the molarity by is actually the volume that I titrated against the acid. So this volume here of 0.065 liters, this was my figure, of course. I'm going to multiply here, 0.065 liters. And what that does is my liters will divide out, and that will give me the quantity of moles of NaOH. So I'm going to plug this into my calculator here, and I get 0.13 moles of NaOH. Okay, so I used this much NaOH. This is how many moles was in that 0.065 liters or 65 milliliters of NaOH. And what I can do now is can compare these two things in my equation. Now this is nice and pretty because these are 1-to-1 ratios. Remember, whenever we do a chemical equation, before we do any stoichiometry or comparing quantities of one thing to another, we need to make sure it's balanced. And this one is, I've got 2 hydrogens, 1 oxygen, 1 sodium, 1 chlorine, 1 chlorine. Acid-base neutralization reactions often are set up in this way, so it makes it easy. So 0.13 moles of NaOH, when I neutralize it, is going to equal 0.13 moles, or require 0.13 moles of HCl. All right, so this is how much acid, okay, the amount of acid of HCl was in the flask. Okay, this is how much was in my 100 milliliter flask. All right, so now I know this. Okay, I've gone from here to here. I've determined how many moles of NaOH I used. The number of moles I use of NaOH is equal to the moles of HCl based on my balanced chemical formula. And then because I started off with 100 milliliters of hydrochloric acid, I can now find the molarity. It's very simple. I take the 0.13 moles of HCl and divide it by the 0.1 liters, and I get a molarity of 1.3. So to rewrite my answer here, the molarity, big M, of the HCl analyte is 1.3 molar. Okay? Box your answer to help everybody out. And there we go. Hope that helps.